All right. Where am I now? Where is it? Yes, Janet, go ahead.
Sir, I was saying one take away two will
Mm-hmm.
give you a negative one
Mm-hmm.
plus the one.
Right. Gives you.
A- And I always say borrow one from Mr. Brown shop and you
Right.
pay him back one you have zero leave.
Right. Right.
Nothing
Or you
leave.
owe one and you have one. So right. Cool. So you end up with zero. So therefore, when x is equal to one, and if you input that in that relation, you're gonna get zero. All right. It's like you give somebody you give somebody $1 million. If you put $1 million in this relation, what are you gonna end up with, class? Nothing. It's amazing, not true? But look at this one. Isn't this interesting? This is saying you put nothing. You put nothing in the relation, and you end up with what? With something. Isn't that amazing? All right. Okay. Which would you prefer though? Nothing for something or something for nothing? I don't know. But anyways, then no, you go to the diagram now. So we're gonna start our arrow when x is equal to 1, and you end up with 0. So you have something like this. So x is 1, and that will go where? That will go towards the what? The 0. That's it. So what I want you to do now, class, is to finish those values. In other words, work out when x is equal to 2, 3, 4, and 5. All right? Are you guys following? Anybody with any questions on what we've done so far?
I'm gonna finish mine.
You serious? That was
Sir,
fast.
I was on last week, so I'm
Oh,
finish it.
from last week. Okay, all right, okay. But maybe we have persons here new. All right. So I'm gonna give
I'm
you.
not gonna give you. I'm not gonna give you. I'm just gonna look.
Okay. All right. So when we're going through, you can probably help us out. All right. Okay. So I'm gonna give everybody 4 minutes. Let me see. How many numbers? 1, 2, 3, 4. 4 minutes to work out those 4 numbers. Go ahead. All right, guys. So I think that was 4 minutes. All right. Anybody need more time? Okay. So when x now is equal to what we have here, 2. All right. Who wants to give us a shot?
I'll try, sir.
All right. Cool.
So it says when x is equal to 2 and y is equal to, I put in back the problem and then I replace x with 2. So it says y is equal to 2 times 2 minus 2 times 2
Hold on.
plus.
So it's hold on,
sorry.
Jody. So it's basically 2 square. So you need to set it out properly, and you probably would have. All right, go ahead now.
All right, so now I say y is equal, well, I simplified or say y is equal to 2 times 2, which is 4, minus negative 2 times positive 2 will give me negative 4, which is minus 4, plus 1. So I have positive 4 minus 4, leave me with 0, plus 1. Now y is equal to 1.
Is equal to 1. All right. So when x is 2, you get 1. All right. So then you go to the diagram. When x is 2, y is 1. All right. What do you know about this mapping diagram here? 2 two different elements go to one element in a range. Not true.
Yes, sir.
Yeah, because when x is 0, it is 1. When x is 2, you also get 1. All right, thank you so much. All right, so who wants to take on the other challenge? When x is equal to 3.
I do that one, sir.
All right, cool. So basically, I'm just gonna set it out like this. So rather than having 2, I'm gonna have what? 3.
3 square, sir.
Yeah. All right, talk to me now.
So it's 3 square minus 2 times 3
Mm-hmm.
plus 1,
Plus 1. Mm-hmm.
which is 3 times 3 would give you 9,
Mm-hmm.
minus 2 times 3 would give you 6 plus 1.
Mhm.
So 6 from 9 would give you 3, and then add 1, which give you 4.
All right, very good. So when x is 3, y is what? 4. So you go to the diagram now. When x is 3, y is 4. All right, anybody work out the other one? Anybody want to try the other one? When x is 4?
Yes, sir.
All right, just give me a minute. Let me just set this up. So when x is 4, and this will be just 4, 4.
Yes, sir. So, you'd say 4 4s 16
Mhm.
minus 2 4s 8 plus 1. 8 from 16 leaves 8 plus 1. So y equals 9.
All right. So when x is 4, y is equal to 9, which is correct. All right. And the last one, class, turns out to be what? When x is equal to what? 5, y is equal to what? 16.
16.
Right. And we call this this diagram is called a mapping diagram, or specifically 1, 1, 2.
1 to many.
Oh, I'm sorry. Hold on. You know what? Before I go there, let's just call it a mapping diagram, because that's what we're going to look at next. I didn't get to show you the types of mapping diagram. Let's call that general mapping diagram. Yes, but I believe, yes, it would be a 1 to many. No, Jody, it would be it is actually a many to 1. The other way around. All right. Okay, but we're gonna actually look at what we call mapping diagrams next. All right. All right. So head up for me. Function.
Sir, quickly.
Yes.
Could you scroll up to the top? Let me screenshot, please.
All right. I'm gonna also send this in the group, so. But if you want to
Oh,
screenshot
okay.
it,
All right, no
yeah.
problem. Send
Yeah,
it
are
in the
you-
group.
Yeah, when this document that I normally work with, I usually send it in the group.
Oh,
All right, class. So we're going to look at what a function is. All right. So remember, we look at relations, and we look at what a function is, right? Now, a function is a relation in which each element in the domain maps to one and only one element in the range. That's a definition. That's a definition of what a function is. All right. Now note, not all relations are functions. All right, let's make a note of that. Not all relations are functions. All right, so I'm going to explain this, what it means, right? So we're going to look at types of mapping diagram. All right, very interesting. So we have what we call a one-to-one mapping diagram, which is a basic one. One-to-one mapping diagram. All right, so basically all right, so one-to-one mapping is really straightforward. You know, it's like you have these elements. So that's a one-to-one mapping. My question to you, is a one-to-one mapping diagram a relation? Sorry, a function.
Yes, sir.
It is, right? Because I mean, look at definition. Remember, you know, on the left-hand side would be our x values, don't you? So let me put it up here. So this is our x values, and this is our y values, right? And it says what? A function is a relation in which each element in the domain, all right, maps to one and only one element in the range. All right. So remember, x values are called what? They're called domain, and y values are called range. if you look at this definition of what a function is, it actually tells us that a one-to-one mapping is a function, because each element, if you look at it, each element over here, so on the left hand side, goes to one and only one on the y. All right. So to answer the question, a one-to-one mapping diagram is a function. All right. So let's look at another type of mapping diagram. It's called many to one. All right. What do you know about many to one diagram? What do you know about it?
Sir, more than the x value can match to more y value.
Well,
Range.
not to more y value, but to one y value. Not sure. It's like two different x values. It's going to the same y value. All right.
Right.
Right. Or two different persons of one girl. Oh, that sound.
Sir, that muse remember it.
Right, but that's what's happening right here. We have two different x values, so you could say, all right, two different persons of one girl. By the way, didn't the last example is like this, many to one? Let's look at it.
Yes, sir.
Yeah, let's look at it. Right. Yeah, this is actually what we have: two different x values. We have when x is 0, it is 1, and when x is also 2, it is also what? 1. So this mapping diagram is actually it's called a what? Many to one. So my question to you now is: a many to one mapping diagram relation a function? Because we know that one to one mapping is a function. Is many to one mapping a diagram a function? Let's look at the definition of what a function is. It says a function is a relation in which each element in the domain maps to one and only one element in the range. Does this definition satisfy what a many to one mapping diagram scenario is?
No, sir.
No, sir.
All right. What is why do you say that?
Because it goes a function goes to one and only one, sir, while a relation goes to many, sir.
Sir.
Hold on.
I think it would be a
Hold on, Jordan. Let me bring the
Sorry.
definition. Let me bring the definition down here. So. Right. So that's the definition. Please read the definition carefully. Look at it carefully. All right. This is x. Remember, what is the x? What is the x called? The domain, not true. And the y is called what? The range. Right. All right, Jody, what are you saying now?
It's a function.
Sir, I think it's a function, sir.
It is. All right, Audrey.
Yes, sir.
It says a function. Listen, what's carefully. A function is a relation in which what? Each element in the what? The domain. In other words,
In X.
everything from X, one person from X is mapped to what? Only one over what? Y.
One element.
All right.
Yes,
So,
sir. I
so,
think
so
so.
RJ, it is actually a function. So many to one mapping diagram is a function.
But sir, it's a one and only one element in the range. But
Right,
with this
sir.
many to one
All right.
diagram,
To be frank with you, the second part of it may be misleading. I'm not gonna lie to you, because when it says one when it says maps to one and only, you're in my mind, or and I know in some of your minds, just saying, boy, only one alone it can go to.
Mm-hmm.
That's what it says. All right.
But sir, I think that one element on the X side is
Element.
matching to one element on the range
Mhm.
side.
Mm-hmm.
Because if we have a zero value, if you have a value that is 0 on the X side and it matches to 2,
Mm-hmm.
and then you have a value that is 5 and it matches also to 2, is only
It's still one and
is
only
only
one.
2, is only X
Yeah.
match to 2 and 5 match to 2. It's
Match
not
to
like
2.
X match to 2 and 0 or other numbers. You only match
right.
to one number
one,
over the
right.
Y
So-
value.
So the
All
one
right, so-
element makes a difference.
Yeah.
Mhm.
Yeah, that's good. So the one on the X actually, makes it says each.
Mhm.
All right. Yeah.
Yes, sir.
Yes.
So by then, it's only one from the X would be the dominant.
Right. Right. Basically, yeah. That's the key. That is the key. Only one person or one value. Hold on here. I think someone is joining. Where do I go? Where do I go? All right. All right. Yes. Yes, Audrey. You're saying.
Yes, sir. It can be more than one on the range, but in the domain it should be one and
It
only
should be
one.
one. Only one something can come from the domain. Yes. Yeah. All right. So that's what the difference is. All right. All right. So we have another type of mapping called one to many. All right. So we have one many mapping. So boy, when I'm in class, I just zoops and just draw the thing in no time. But boy, it's near us. All right. So I keep on forgetting to put the X. And Y. All right. Now with one too many, you see, this is how it looks. Or look at this now, class. What do you know about one to many in terms of domain and range?
One domain matches to more than one range.
Right. One element is going to what? To two different range. All right. Everybody see that? So my next question to you is one to many mapping relation a function based on the definition? Where's the definition? A function is a relation in which what? Each element in the domain. No. Is this each element? No.
No, sir. It's not a
No.
function.
Right. So one to many is not a function. All right, but it is a relation. Make sure you know that, right? All these diagrams, they are what? Relation diagrams. All right. Now, previously, I would say that we can represent a relation on a mapping diagram or on a what class? On a graph. All right. Now, how do we determine when a graph is a function or not? That's my question to you. Because we know how to determine whether a mapping diagram relation is a function, not true? But how do we look at graphs? All right, so all right, now how do we determine if this graph is a function or not? It's very simple. All you need to do is to draw a vertical line coming down with a ruler, of course. All right, somebody wants to join the class. Some highs. Okay, so what we do, we draw a vertical line through these diagrams. Let's draw a vertical line. Now, what you notice, but for this graph here, it cuts it at one place. Cuts it at one place for this one, but if however we draw a line like this, how much place it cuts it? 2. All right. Now, if you draw a vertical line through the diagram and it cuts it at one place, it's a function. So as you can see in diagram A, so A is a what? A function. What about this diagram here? Is this diagram a function? Yes, it is a function. What about this one here, so? It's not a function. Because what? One x value has how many y values? 2. So this relation is not a function. Everybody following?
Sir, can go over that again for me, please?
All right. If you draw a vertical line through the graph, And if that vertical line cuts the graph at only one point, then that relation, that graph, is a function. So you notice that I would have drawn a line through this curve here. How many places cut it? How many places this line cut the curve? 1. All right. Look at this diagram here. I draw a vertical line. How many places it cuts the diagram? 1. If it cuts your diagram, if you cut the diagram at only one point, then that graph is a function. Otherwise, it's not a function. So for example, this one here, this one at the bottom here, so this one. How many places does that straight line cut the graph? 2.
So
Right. Because it cuts at 2 places, it is not a function. In other words, one x value has how many y values? 2. Yeah. So it's one x value and 2 different y values. So that's what you need to look for. All right. Any questions? So the answer for this is if we draw a vertical line through the diagram and it cuts it at one point, then the relation, which is a graph, is a what? A function. Otherwise, it's what? It's not a function. Meaning, the line cuts the graph at least 2 places. Everybody follow?
Yes, sir.
All right. All right. Moving on. I'm gonna send this. I'm gonna send this to your to the classes here. All right. Let's look at one more thing. Let's look at this question. Determine which sets or set of ordered pairs is a function or not. All right, so we can also determine it from ordered pairs. All right. All right. Look at these ordered pairs, right? All right, my question to you, does this set of ordered pairs represent a function?
Yes, sir.
Yes, sir.
Right. Because look, if you remember, all right, let me show you something. You see the mapping diagram? The mapping diagram is just like putting all these numbers together. All right. Notice with a one-to-one mapping diagram, all of the numbers are different. Not true? Yeah, look at it. Nothing match nothing. X is 2, X is 3, X is -4, and 0. Y is 4, Y is 9, Y is 0, Y is 8. So everything different. All right. So if you're asked to draw this as a mapping diagram, you'll get a what? A one-to-one. All right. So this relation is a function. And if you're to put it on a mapping diagram, you'll get a what? You'll get a 1
1-to-1.
to 1 mapping diagram. What about the second set of ordered pair? If you're to draw that on a mapping diagram, what type of mapping diagram would you get?
1 to
Many to 1, sir.
oh,
many
yeah,
to 1.
1 because from the Y today.
Many
Many to 1.
to 1. Because guess what? No, remember, in a many to 1, let's go to many to 1. We said that this was a many to 1, right? Well, notice
Sir.
two different X values, 0 and 2. Both of them are going to what? 1.
Number 1.
Right. In other words, two different X values have the same Y value. So if you look at these numbers here, we notice 7 goes to a 6 and 8 also goes to what? 6. All right. So we notice 7 and 6 are going to what? 7 and 8 are going to what? Going to 6.
6.
So that's a many to 1. So this is actually, this relation is a function. All right. But what about the last one? If you're to construct that on a mapping diagram, what would you get?
1 to many.
1 to many. Right.
A function.
But is a 1 to many mapping relation a function? No,
No, sir.
it's not a function. You know why? Because guess what? Two X values, look at it, -5 and -5. In other words, -5 goes to 9 and -5 also goes to what? 10. So it's something similar to this mapping diagram. Look at this. If you look here, this is 5, 5 is going to 2 and 5 going to what? -2. So I'm saying? So that's not a function. Look at 51, class. How do you work on that one?
Sir,
Mm-hmm.
I would use the answers in A, B,
Mhm.
C, and D to represent the values X.
Mm-hmm. Very
So
good.
if the
Yes.
first one to, okay.
Yes, that's true. All right. So this one question, I'll have to end with this question here. So basically, what they're saying is, Bruno, these are X values, right? 0, 1, 2, and 3. All right. So if I put 0 in this relation, I'm supposed to get what? 3. If I put 1 in this relation, what should I get? 4, etc., etc. All right. Oh Lord, I just realized that this thing don't have an eraser, All right. All right, so basically, let's try A. All right, so if I put 0 into this thing here, I must get 3. What is 0 square? 0. What is 0 plus 3? Where you get? 3. So it works. So this one good. Everybody see that?
Yes, sir.
Let's put 1 in this relation. So what is 1 square? 1 times 1, which is 1. What's 1 plus 3? 4.
Yeah.
So it works. Let's try it for 2. What's 2 squares? 4. What's 4 plus 3? 7. Wow, it works. Let's try the last one. What is 3 square? 9. What's 9 plus 3? 12. So that's the answer. Any questions? Alright guys, so I'm gonna end the session. I'm gonna send this document. Alright. Okay guys, so I'll see you. I'm gonna send this document in your WhatsApp. Alright. So I will see you guys next week.